Okay. So, your data sheet actually has 3 kind of studies. One involves giving caffeine to males and seeing how it affects their cycle performance, in particular their heart rate on bike. What was the surprising result there? Why are we reading about this? Remember what the surprising find was in that first study? Why were we even reading about it at all? Right, Danielle, caffeine lowered heart rate for certain levels of cycling activity. Hummingbirds flew by the way, that's quite cute. So we weren't expecting that. We were expecting caffeine to raise heart rate, as it usually does. But then at this certain level of output, caffeine lowered heart rate. Well, that's interesting. That's interesting because it shouldn't have happened, but it did. So we wrote a paper about it. And we reported our findings. Beautiful. The next study that we looked at, which we'll start with again here, was green tea and its effect on breast cancer rates. Now, the study itself doesn't make any real mention of this until you read it more carefully, but the entire study was done on which population?
Chinese women.
Right, Asian women, correct. So, there are other variables at play besides just the green tea. And you guys named a few of them last time, correct? What are some other variables that might also impact the breast cancer rates? Diet of an Oriental population versus Western population. Eastern versus Western population. At least for years, there was no fast food in Eastern populations. Now that we've seen a creep of fast food creep into those populations, we're starting to see some dietary changes as indicated by health problems. Something else that I have not been able to track down, my brother-in-law now lives in China. He mentioned a spike in cancer rates in the province he's in. And I did a little bit of digging, but not enough to find anything statistically significant. But it's the region where quite a lot, you know, you guys recycle cell phones or recycle electronics, you know, your iPad dies, you recycle, you don't just throw it away, you can't just throw it away. But you can recycling bins at Best Buy for batteries and things like that. When you recycle electronics, those electronics are full of heavy metals, which can be reclaimed and reused. But it's a highly labor-intensive process. I mean, these parts are tiny, you know. He sent me pictures that he had taken of a guy with a pile of dead cell phones in front of him, a Chinese gentleman, going through barehanded, nothing covering his face at all, ripping the phones apart and pulling the parts out, making little sorted piles. Now, the whole concept of that makes me sick to my stomach a little bit, because the fact that he's not covering his face at all, he's working in a completely uncontrolled environment, means he's exposing himself to those very carcinogenic type materials that we're talking about with higher cancer rates. What depressed me even more is his children are playing right around the pile that he's ripping through. And he's telling me, and again, this is all hearsay so far plus the picture that I've seen, a lot of those phones that you guys recycle end up in the province he's at, that he lives in currently. And that's where he's noticed, and I'm saying noticed with quotes, we're not talking statistical significance here, we're only talking anecdotal reporting by my brother-in-law, that the cancer rates have shot up in the 5 years that he's been there. That could be a fluke on the radar, but it depresses me a little bit knowing that people are in there with absolutely no protective equipment whatsoever, ripping cell phones apart, exposed to no heavy metals. That's something else that could be influencing the breast cancer rates in a negative way in this study. You see what I'm saying? There are other variables. So when you think about that, this is why, as soon as I found out about that a couple years ago, I stopped recycling electronics. They're now sitting in a drawer in my garage, which, whatever. So my son can play with them, I guess. Please, Rosie.
That's actually like a huge problem in a bunch of different third world countries, and it's usually kids who are doing it.
It's the kids
that are pulling apart the...
Oh my God, yeah, it's even worse. So this guy, the adult doing it.
Yeah.
So, and again, I have nothing except anecdotes here. I've got no support for this. I can't find any research online, probably because it would be horrific if it ever came out if the research had been done. So if you guys are looking for a good research project, what's your research methods? One might exist. I think it's Yangzhou province. There might be a good one for you guys to blow the lid off of. CNN would love you guys if it actually showed something. Anyway, why were we reading the green tea paper? Why did we care about that one? Because, what does it appear that green tea is doing? It looks like green tea, all things being equal, is lowering breast cancer rates. Now, suppose the researchers are trying to see if green tea is in fact lowering breast cancer rates. What are they going to start by assuming? and this is the key, if you can get this internalized today, the rest of the class goes much easier. If they're trying to show that green tea lowers breast cancer rates, they go in, Drew, by thinking that it doesn't, which is your null hypothesis. It seems kind of silly to put that second, but here's why I put it second. Because what you put first is what you're trying to show. That green tea appears to lower breast cancer rates. The opposite of that, green tea does not appear to lower breast cancer rates. So not only does it not lower them, it might in fact raise them. The polar opposite, if you will, the polar opposite of what the active result of green tea consumption would do. Beautiful. Okay, now here is the result. Here is the result. Could somebody verbalize what this means? We did a lot of conditional probabilities last time. This p-value, Eric, you're the one that grabbed it last. I remember on Thursday you grabbed that. You said, that's the first thing that jumps out at me.
Oh yeah, it's got to be lower than 0.05.
Good, good. Eric says, in order for us to believe something has changed, that has to be lower than 0.05. Tell me why. Anyone, tell me why we care about 0.05.
So it's out of that 95%.
You make me so happy, brother. Am I looking at that 95% right here? I am. I'm looking at the 95% confidence interval. It looks like it's lopsided. It doesn't look like a normal confidence interval that's got a start and a stop. This one's got a start and a forever tail. Is that okay? Better question, why is that okay? Yes, it's okay. That's a stupid question. Yes, it's okay. Why is it okay? How is 95% represented here? And I think Cassie hit this last time, I think, if I remember correctly. I could be remembering incorrectly, though.
It's too early.
Say that again?
It's too early.
It's too early! When you guys are making two-sided confidence intervals, like you are for the exam on Thursday, when they got a low bound and an up bound, is there 95% area between those two bounds? So what's over on the left tail outside? How much? 2.5%? 2.5%? And then how about on this side? 2.5. Okay, so there's 95% in the interval and 5% outside. But with a two-tailed test, 2.5 is down, 2.5 is up. How about with a one-tailed interval? Is it still 95.5? Yes, it's just that the 95 isn't completely symmetric anymore. Why would we want a one-tailed interval like this versus a two-tailed interval like the one for Thursday? And the difference is how the course is changing slightly. Suppose, for example, this was a two-tailed test. Suppose we had 2.5% of area here and 2.5% of area over there.
Cancel each other out.
Well, they would, at least logically, because then our research hypothesis, and sometimes we do want this, and we'll see why as the course goes on, I promise you. Sometimes you do want two tails. But we're only testing in this test. The research hypothesis is that green tea did what?
Lower.
Say that again?
Lower.
Lowered cancer rates. Not lowered or raised. We're not testing that. We're just testing that it lowered cancer. You see what I'm getting at, friends? So we're only interested if he lands over here. Now, I'm not saying, if this asterisk landed way the hell over here, I wouldn't be interested. I'd be very interested, and I would burn all the green tea that I have, assuming the study was done correctly. Right? You see what I'm getting at? So that's why you can't blindly look at a p-value and ignore it if it's above 0.05. If it's 0.99999999994, you're like, well, it's above 0.05. Yes. And maybe we're testing the wrong thing. And we'll come back to that as well, with some Florida data that we'll look at later on next week. But the idea is, the reason this is a one tail, a one red tail over there, is because we want to see if that asterisk pushes far enough away from this, which is that 95% confidence interval that Eric was talking about. Thank you, sir. Thank you, sir. Good so far? Who wants to hazard a guess at phrasing what this means? 0.001. It's 1 in 1,000. It's a 1 in 1,000 chance. It's pretty rare, right? That shouldn't happen. 1 in 1,000. That's like rolling a pair of dice like 5 times and getting snake eyes every single time. It's pretty. Oh, that's not quite that low, actually. It's like rolling 3 times and getting snake eyes 3 times. It's more like that. But still, would you expect to roll a pair of dice 3 times and get snake eyes 3 times? No, you probably think something's wrong with the dice. So, what does that tell us? What does that tell us? asked a different way, what is right here? What's right here?
Average number of cancer rates for population.
That's perfect. The average cancer rate in the population without green tea. Ignoring green tea, or if you will, drinking and not drinking, altogether, it's the average cancer rate, average breast cancer rates. As we move to the right of that, what's happened to the breast cancer rates? They're going up, and they're getting less likely. It's getting less likely that you'd have a cancer rate that high. And as you get far enough out, a cancer rate this high is basically not going to happen. Is it fair enough? Fair enough. Okay, so here's average. Average because it's a bell curve. Average because it's the mode, it's the median, it's the mean. It's all three things. Here are lowered cancer rates, but not unusually low. Within, if you will, the margins of error of the sampling distribution. But what happened with our data? We got some low rates. We got such low rates, in fact, they're off the chart. This is like bringing your kid to the pediatrician on their second birthday, like Max, on a second birthday checkup. He's in the 110th percentile. Okay, how about you just say he's off the chart rather than make up a statistic? He's off the chart. Or he's in the first percentile because he's this big at age 2. When you bring a kid at age 2 that's this big into the pediatrician, you don't pat him on the head and say, my goodness, you're adorable little Ewok. You start thinking that he doesn't belong on this average curve anymore. And you probably would have noticed it before age 2. But the idea is, if that kid is so far down in these tails, he most likely does not belong to this curve. And the logic applies here. If we saw cancer rates that were so far down in this tail, there is one of two options that we can believe. Number one, those cancer rates do belong in this chart, and we just got ridiculously lucky and got them. That's one way to view it. But that's kind of silly. That's kind of silly, because that's believing in luck. Okay? That's believing in luck. And when you talk about a random sample, there is no such thing as luck. So the other logic is that this does not belong on this curve and belongs where? Belongs where? Wait. Where does it belong? On some other curve. It belongs on some other curve. This is a couple pages. We've already been through these on Thursday, but just a quick review will not kill us. So that red asterisk is so far left of the non-green tea drinkers' cancer rates that it's hard to believe it's on that curve at all. It's much more likely that it's on some other curve to the left. Now here's a question. What's the center of this curve? What's the center of this curve? It's a trick question, by the way. What's the center?
We don't know.
We don't know. All we can say is that it's what?
Lower.
That's what we can say. It's statistically significantly lower. Now this is where Jesse's going to say, wait a minute now. What is the difference? It goes from 6% to 5.99%. To which I say, that's lower. Not practically necessarily, but definitely statistically. Fair? Good? Maybe. But that's the idea. We're only testing statistical significance. We're testing the fact that the confidence intervals aren't touching. If the sample's large enough, the intervals are going to shrink down like this anyway, and eventually become essentially points, so they can't touch. So any difference can be made significant if the sample size is large enough. I'm not saying it's practically significant, I'm saying it's statistically significant. So, what can we conclude? Here's our data. Here's our data. It looks to me like something happened, because we were expecting green tea to have no effect whatsoever on cancer rates. But, my lord, we got lowered breast cancer rates. What's that called? What's that called when the first part of this probability disagrees with the second one? Remember what that's called? I mean, I did the geometry. I can prove that. I think made you all nauseous that day. Say that again, Liz. Good! It's a contradiction! If we're expecting it not to have an effect, and it has an effect. Whoa. That doesn't make sense. That means everything we were assuming is most likely wrong. Which means we were waiting for this, but we instead got this. So it looks to me like the green tea, all other things being equal, which is a loaded statement, isn't it? If we've controlled for everything else, green tea is lowering breast cancer rates. That's a huge if, you guys realize, right? It's a humongous if. in the study. But all things being equal, we got ourselves lower breast cancer rates. How much? Confidence intervals help us answer that question. We'll get into that. We'll start putting the confidence intervals with the hypothesis test in time. Right now, I just want to focus on these p-values and what they're implying. Ask me questions. Ask me questions. Yeah? Ish? The trick about these studies, just to go with my friend's new slideshow, the trick about these studies is that almost every one I've ever seen takes place on Asian populations. I have yet to see one done, except anecdotally, in America. Because green tea is not anywhere near as popular here as it is in Asia. And the Eastern drink it way more than Westerners do. Now, I think that's changing. I mean, not that this is proof, but it's changing. I mean, I've grown to like the taste of green tea over black tea. What's interesting, it's the same plant. That's the part that blows my mind. Green, black, white, all the same. All the teas are the same exact plant. That's how it's processed. And the processing changes the chemical characteristics of what allegedly fights the cancer cells. Pretty interesting stuff. Pretty interesting stuff. Okay?
So at this point, we're not saying.
Will, go ahead.
We're not saying at this point we're 99.9% sure that the average is lower.
I love that.
Can we say that?
We can't say that because the problem with saying that, I mean, you can say you're 95% sure, but you can't say 99.9% sure. Can anybody see why we can say 95, we can't say 99.9? See where Will's getting his 99.9 from? You see where he's getting that from with that p-value? Why could we say 95, but we can't say 99.9? Does anybody know? This is a very, very slight. Drew, go for it.
Is it off the charts?
It is off the charts. And that's... Hold that thought. Danielle?
Is it because there's 95% of your data is under the green curve?
And what did we use? I'm going to back up one more curve. It's okay with you guys? Okay. Here's the curve we made our decision based on, correct? I added another curve later. We made the decision we made because, Danielle, we said anything past that is unusual. So we made our decision based on 95%. Will, is that fair?
Yeah.
The 99.9 is the extra area we pick up if we go out to here and then work back from there. The reason we shouldn't say 99.9 is because if I ran this study again, that's what Drew was getting at. If I ran this study again, would I get the exact same p-value the next time? Probably not, because there'd be sample variation. So what would happen, most likely, if this is not an outlier, that's another big if, right? If this is not an outlier, this guy would shift around. Maybe it's a little closer to here, maybe it's more like 98%. Maybe it's over here even further, maybe it's 99.992%. You can't make a statement based on the p-value with confidence, because they're not the same thing. Basically, what the p-value does is it either puts you in or out. And what is it putting you in or out of? The interval around the null hypothesis. This is the interval. This guy right here, the reason we like this so much, it seems weird to have proof by contradiction, as Lindsay pointed out correctly before, but the reason we use it is because we know what this looks like already. We've tracked cancer rates for years and years and years and years and years. So we know where the usual or elevated cancer rates are. What our data says is, does it look like we're here or does it look like they're lower? It looks like they're lower. So you got that part nailed, Will. It looks like they're lower. But the confidence is at 95%. FYI, thank you for the segue actually. When we say 95% confidence, these tests, these hypothesis tests are also sometimes called tests of significance, just FYI. So let me give you a symbol that's often used. I'm not sure how much it's going to be used in the future, because things keep changing, it seems. But when we say there's 95% confidence, that corresponds to an alpha level of 5% significance. Significance, G or C? Significance? Significant. Significant. Is it a C or a G?
It's a C.
Is it a C? Is it a G?
C.
It's a C.
Yeah.
Significance. I say with a G, significant. Significant. I say with a G. Oh, is it significant and then significance with a C? Thank you, English language, for sucking. Yes, it's basic. Thank you, English language, for being a pain in my ass. I learned last night reading Ranger Rick that baby porcupines are called porcupets. Thank you, English language, for being cute and annoying at the same time. Porcupets. You ever seen a porcupine in the wild? They're adorable. They're adorable. They're adorable. Don't get too close to them. I'll kick your ass. You ever see a baby porcupine? Adorable. Actually, I haven't seen one. I took a picture last night. Anyway, I think I'm here to tell you that. 95% confidence equates to, this is alpha. We'll talk more about alpha momentarily. Alpha refers to significance. And these two numbers are always complements of each other. Why we have two different phrases, I don't know. We just do. Okay, that's statistical language. So hypothesis tests, like the ones we're going to be doing soon, are also called statistical tests of significance. Significance.
Now you gotta move on there.
Nah, I don't know, it doesn't matter. Alpha, just call it alpha equals 5%, ergo, forget the English altogether.
My phone says it's a C.
Cassie's phone says it's a C.
I think it's
Predictive text it.
Predictive text it.
Yeah.
Well, it keeps, yeah, but you know, that predictive text crap, every time I type hell, it changes it to heal.
Yeah.
H-E apostrophe L. No, I'm saying hell, like hell yeah.
Not like he will.
But it's not contextual. Heal yeah, what? And the it's thing, I'm typing ITS and I mean it's.
Yeah.
Like it's head or it's feet, it's taking an IT apostrophe S, that pisses me off. I'm a recovering Catholic school boy. Grammar was drilled into my head.
Right.
That's why that drives me kind of
C-A-N-C-E.
I trust Cassie. Will, go.
So for now, for our purposes, 0.01 is kind of the same as 0.001.
0.0, yes, anything smaller than 0.05 is in that tail. Yes, and that's one of the things that it takes a while to get used to, because if you do a study and get a p-value that's got a few more zeros than this one, you're going to think to yourself, wow, that's super significant. Not unless you were testing at a higher confidence level. It only becomes significant if you're putting a breakup point that's more than 95%. So yes, anything past 5%, which raises the interesting question, what if it's 0.04992? How do you feel about that? We'll come back to that, I promise. I don't want to get too nitpicky about that, but what you just said is perfect. Anything that goes past 5%, smaller than 5%, is essentially the same. Thank you, sir. Perfectly said. Are you in? The big question is, are you in or out of the interval? And that's your guide for are you in or out of your interval. Cool so far? Great wrap up there, Will. Okay. One more article in your data sheet. Take some time and read that bad boy. It's a secondhand smoke article. Say that again?
What's a crossover?
I used to know. Don't anymore. That is what I'm worried about too much. But I should know the answer to that. Not ringing a bell. Single blind makes me a little bit concerned, but not super concerned. No, I don't remember. Unless it means it was another word for AB. This was done overseas in Europe. They have a different phrase for it. I mean, it's also an AB or ABA study, which is what this actually was a pre-post baseline measurement baseline. That could be what's crossing over. It's crossing over the experimental value. Let's find out. Terminology kills me sometimes. Longitudinal study with subjects with sequence of different treatments or exposures. So it's basically a baseline study. Assuming Wikipedia is right. The observational and control experiments, which this was. Crossover designs are common for experiments in engineering, psychology, education, public science, medicine. Healthcare, good. Different arms of the study, two different treatments. Yeah. So you've got, and what they talk about in this study, which you'll read momentarily, is exactly those different exposures. Does anybody have are they around? Oh, there they are. I just want to grab a copy too. So the great question from Chris, let me stop this, or stop recording.